Well, welcome everyone to another in-depth webinar. OpenTEAM's in-depth webinar series is meant to build the knowledge base of our community in a way that fosters coherence and collaboration so that we can better serve our ever-expanding and diverse membership. And we really hope to illustrate and document the dynamic nature of our community in support of strengthening it, and as well inspire and share new concepts and technologies that enable the emergence of new collaborations and tech approaches. Today we have Paul Hishmeh. He's the Data and Technology Director at Field to Market, the Alliance for Sustainable Agriculture. And he is going to introduce us to kind of the Fieldprint platform and also how their sustainability metrics are implemented and used through API integrations. So without further ado, I'll toss it to you, Paul, and thank you so much for joining us today.
Sure. No, thanks very much. Appreciate it, Laura. And thank you for the opportunity. I will share my screen here and hope that everything works out. And that Zoom.
We see your screen.
All right. Let me see if I can. Is that all working? That's good.
Yes. Yep.
Good. All right. I'm just playing with my two monitors. So, well, no, thanks everyone. Again, appreciate the opportunity. Paul Hishmeh from Field to Market, Data and Technology Director here of our small 10-person shop. But really happy to join. We're recently engaging with OpenTEAM. And really appreciate the opportunity. I had some good calls so far, elicited a lot of, I think, interesting information for us. I saved one slide at the end to kind of talk about, where those intersections are between Field to Market and OpenTEAM, sort of what sparked our interest. The presentation here is really sort of through the lens of just sharing some of the implementation aspects of the Fieldprint platform. It's not an overview of Field to Market. I have a couple slides on that. I would encourage anyone to, definitely look at fieldtomarket.org for any information. This is really sort of a little bit of a scattered presentation just to try to show you some of the things that we've done in our implementation. I included some slides on the challenges we've done. And again, I think as I've experienced some of the other calls with OpenTEAM, I just thought it was a way to sort of share somewhat openly some of the things we've dealt with and maybe some of the approaches we've taken. So this isn't a super polished presentation. It's more just one to share some different aspects of Field to Market. So I'll start here though with a brief thing on Field to Market. We are the Alliance for Sustainable Agriculture. Our overarching goal is to define, measure, and advance the sustainability of food, feed, fiber, and fuel production in the United States. We have a number of tools and programs, and with our common sustainability framework, we really work with farmers and organizations to better understand and characterize sustainability. So that's our purpose in life. We have our roadmap and our strategic plan and so forth on our website, which I think would provide some interesting information and also provide some detail around our program, our members, our continuous improvement accelerators, or the catalyst for how supply chain partners get together to look at sustainability. I always do like to include our slide of our members. I think we have, that's not my feedback. Oh, somebody's. We have, I think, around 140 members so far in Field to Market. Really proud of that membership. Field to Market has been around for, I think, a little over 10 years now. Our membership is divided into sectors: agribusiness, brand and retail, growers, civil society, and affiliates. And what's important about that, if you look at the governance of Field to Market and sort of how we drive the program as a whole, it's sector balance. So each of those components or sectors of the supply chain have a say in the program development, have a vote, participate in the committees, and so forth. And that's really important to how our sustainability program develops and unfolds in a way that sort of brings value to everyone involved. So this now dives right back into sort of looking at the Fieldprint platform. When we talk about the Fieldprint platform, we're really referring to our metrics engine. That's the underlying calculation for sustainability measurement, our Fieldprint Calculator, which is a web-based tool, and an underlying Fieldprint API. So we talk about the platform. It is our assessment framework for the supply chain to look at continuous improvement. In a nutshell, management information for a grower is inputted into that platform to generate a sustainability performance score for them, graphical representation, but also tabular data, which we'll touch on a little bit. It is generally simple in concept, although there's a lot of complexity behind the scene, some of which I wanted to share today. There's also a lot of involvement from outside sources, the data that we use and methodologies and so forth from different sources. This is a very, sort of stick figure block diagram of the platforms. Looking at the bottom, we have those that interact with our platforms. So we have farmers or producers. We have a concept of continuous improvement projects. That's really what brings the supply chain together around some purpose, looking at certain sustainability areas, greenhouse gas, irrigated water use, working within the supply chain in groups of growers on a registered project to look at that measurement as a whole. So that's the concept of project. So practically that's project administrators and project specialists, maybe sponsors that would interact with our platform. They could be working with qualified data management partners. These are our API partners or outside providers. They could be working with the Fieldprint Calculator. And either way, beneath the scenes, underneath is the Fieldprint API that we've developed that interacts with our metrics engine, really the calculation for our metrics. We do interact, which I'm going to touch on, with USDA NRCS models, working with Colorado State University, and then we are hosted on Amazon Web Services. And for those interested, there are some technical things just to give you a sense of our technology stack. Generally open source. Again, we're on AWS. We use Ubuntu, Apache, Python, some of the frameworks you see there, the Django, React, Redux, Material UI. We used Google for our mapping. So that's kind of the underneath the covers of our platform. When we talk about our metrics engine, these are the sustainability metrics that are being measured for a grower. These are the things we look at. This is part of the analysis listed there to the right in the green box, those 8 sustainability metrics. That's really the cornerstone of our program. That is the purpose of the Fieldprint platform. It is to implement a technical infrastructure to deliver that sustainability measurement. It serves as an industry standard measurement framework throughout the supply chain. It is very much science-based, developed through a multi-stakeholder governance process. Allison Thompson is our VP of Science and Research, has been at this for quite a long time, directs that effort around the science that leads to the metrics. We have a metrics committee. We have an outside science advisory council. So quite a bit of time, effort, and expertise goes into the development of the metrics. At the end of the day, at a practical matter, they were developed for growers of 12 commodity crops that we support. And a lot of what we do feeds into educational materials, whether that be, of course, for growers and producers, for those involved in projects. We work with ag retailers. We have an ag retailer education program, certified crop advisors, and so forth. So we have our technology, we have our science, we have our education, we have claims and verification. So we have all these sort of components of our program as a whole. We have certain principles behind those metrics. A diagram there is our spider diagram, or radar plot, which is often how we convey the meaning of the results. But really what's important is that each metric measures a specific environmental outcome. Each one is important for environmental sustainability, as you would guess: biodiversity, soil conservation, greenhouse gas emissions. It's at the scale of the farm, typically measured at the field level, responsive to change in farm management. An obvious goal here is to have the inputs to the metrics be those things that a grower can control. And then, of course, based on science, and that supports the accurate modeling of that environmental impact. I wanted to touch on, because I think it's worth highlighting here, that we have a close coupling with USDA, NRCS, and Colorado State University. We have an MOU with NRCS that supports the expertise that we need for the model and data services that ultimately feed into our metrics engine. So our metrics engine has some homegrown calculations, but a lot of those metrics you see, like soil conservation, soil carbon, water quality, a lot of these are NRCS or USDA more broadly models. So we are very thankful to have the support from USDA, NRCS. We work with Colorado State University. at their Object Model Systems Lab out in Colorado. And I listed there some of the primary models that we use. Not surprising, we use Water Erosion Prediction Project, Wind Erosion Prediction System. We use Soil Conditioning Index, Water Quality for Ag, CRL Land Management Operations Database, and then others like STIR. We use CliGen for climate data. So we use quite a bit, and I'll expand on what we do with those NRCS models and how we interact with Colorado State University. There is a link there to read more about CSIP if you're interested in what other services they provide beyond what we use. These are the crops that we support in our platform, whether it be in our calculator or through our qualified data management partners. Version 3.0 came along, we added crops like corn silage, sorghum, I think sugar beets. We will add more over time. We're focused on commodity crop production, obviously. We will add them in response to the supply chain and to our members. So there is a process that we go through to add new crops. We also need a lot of the background data that supports calculations for each crop. But this is the set that we support today. So thinking about our Fieldprint Calculator, thinking about those few components of our platform, the calculator is our web-based tool. It's been around since 2009. Started out in its early incarnation as an educational tool. I know in a recent OpenTEAM call, there was a lot of talk about technical debt. Well, 2018 was our year for technical debt. Thankful to our membership and other outside supporters that provided the funding for a major overhaul of our platform from version 2.5 at the time to what is now version 3. It remains a freely available online tool for farmers and those that are managing projects within that calculator. Provides basic functionality, which we'll touch on in a couple slides, for farmers, for admins, and of course it supports all 8 of our metrics and all the approved crops. So I didn't think a demo of the calculator was helpful here, but just wanted to highlight in some very tiny screenshots some of the functionality, or what we would refer to as baseline features you would see in the calculator, and you would most often see in some of our API implementations, not in the same UI model, but in terms of functionality. Growers can obviously visit their dashboard to see the farms and the fields that they've entered in the platform. They can look at the crop year. So we talk about crop years as a 2020 corn or 2019 soy. Everything is analyzed at a crop year level. They have the option, of course, for data entry, from the rotation information to management information to operations related sort of as applied type data. There's a crop rotation library, which I'll touch on a little bit more in a moment, that feeds into the models. Then, of course, the analysis page, and then the detailed reporting that an individual grower would get for the performance of their field. Then for an admin, again, a specialist or a project admin that's now part of a supply chain project, let's say it's US Rice working with Ducks Unlimited in Louisiana with NRCS and 100 growers, to look at water quality and habitat, right? That's the concept of how field to market operates, looking at continuous improvement. We have baseline features for administrators now that are in charge of those projects. So they could obviously go and see the listing for projects with which they're connected and they have permission. They can then drill into a project and see details, who are the sponsors, who are the partners. I should add, of course, growers opt into those projects with a unique key. Then there's the tracking of that project, how many acres, how many farms, how many fields, how many growers, irrigated, non-irrigated, and then also grower management of those 100 growers in my project. Have they all calculated their results? Have they marked all their fields final? Are they ready to be brought into reporting and then used for analysis? And then we have various reporting options for them, from just a data dump of all the data to some of the reports, such as dump your shape files for all your growers, dump or get reporting for companion programs such as SCI or TSC, the Sustainability Consortium. So we have a lot of crosswalks with other programs as well. I wanted to touch on the crop rotation builder. This kind of feeds in to our work with NRCS. Those models require crop management template. We've had the slide doesn't speak to the volume of work we've done with NRCS and Colorado State University to try to make sure we stay lockstep with their standard for crop rotations. So we interact with CRL mod to allow users to either use an existing crop management template or now build a custom template. So I won't get into the details of LMOD, but anybody familiar with it understands sort of what existing templates are, how reliable they might be, or whether they're meant to stitch together. We found it was necessary to provide functionality that allowed a user to be able to create a custom rotation. And our API partners now can pass a custom rotation as well. And that custom rotation also gets passed along to the models within the metrics engine to produce things like the erosion data. So, and this is also important because Field to Market, through a grant, is working with NRCS to find ways that growers can take their data in the platform and also carry that over to NRCS. Let's say they're working with RSET or CART. We want to be able to provide that rotation file that would be used by NRCS if they did deeper analysis. It's the same format used in the integrated erosion tool. So because we try to stay so closely knit with NRCS, we really spent quite a bit of time and went through a lot of lessons learned building out a crop rotation builder in the platform. And this is just a quick view. I won't drill down on it, but this is an example of a grower in our platform who has a crop rotation. He's got a corn soy rotation. You can see there's a validation error on the one. Beneath it is one that is valid that he may apply to his crop year. Maybe I'm looking at 2020 corn. I put in all my inputs. Now I want to create and attach a crop rotation template that will be used for my erosion modeling. And this is an example. If I were a grower and now wanted to customize my rotation, I could bring up that rotation and maybe I want to add a planting operation, specify the date. This is giving an example of how we interact with the CR LMOD service at Colorado State University to allow a user to pull in any type of operation. If it's an operation with crops such as planting, then they would pick the crop. If it's a residue adding crop, they would have an option for residues. So we have an entire API service in the background that's interacting with Colorado State University around the crop rotation builder. And this is just an example of the details of a crop rotation where you could see, the details. This one has a sprayer operation, it's a killing operation, fertilizer, and then you see the planting of the soybeans and another spraying operation. So I raise this because one of the challenges we have is we ask a lot of questions you wouldn't be surprised to ask, like, oh, what you fertilized or fertilized, how much did you add? You irrigated, how much water did you apply? You seeded, but we didn't always ask for dates and we didn't always ask for exact timings. And we have a little bit of a challenge now with the need to sort of answer the mail for the inputs that the models require, but also what we originally required in our metrics engine. We need to find better ways of sort of pairing up that data. Right now, users, I think, often feel like they're duplicating their data, but in slightly different formats. So it is where it is now, but we're working on improvements around that. And for those interested, this is an example. The .rot file is a JSON format for crop rotations. This is what our API partners use. This is behind the scenes in the calculator. Again, this is just the format that we pass. You can see in here at the top, this is a spraying operation that you saw on the previous screen. Some of the details, such as the operations date. If this were a crop, like a planting, you would also see a crop ID. So again, just to give you a flavor of some of the stuff that we do in the background. And then anybody that's looked at the calculator is sort of seeing how we present results, whether it's a grower going in our calculator, working through an API partner. We have sort of a standardization around how results are displayed. So we use the spider diagram quite heavily. It is a graphical depiction. The smaller the footprint, the better the performance. You see our metrics sort of around that radar plot. You see a tabular view. Just for explanation, I pulled out a greenhouse gas score, the 33.6 score of pounds of CO2 equivalent per bushel. And then we take it a little further and we show the user how that breaks down. So if your GHG score is X, where did I get that from? There's some of it's at soil N2O emissions. I have some that may be coming out of my seed energy, some out of my management energy, which is fuel, which we take out of the crop rotation system from CR LMOD, et cetera. So we break that down for energy as well. Also for erosion, we break down whether it's wind or water erosion. So this is just to give you a flavor of the types of things that we present back to a grower. For our API partners, we have a canned report. They can take the data and display it how they want, as long as they use the spider diagram for consistency. Or we have a PDF report that's formatted that they can just, each request produces that report URL that they can use. So then our API is really sort of behind the scene, is sort of that technical plumbing. I know a lot on this call are technical, so this slide was probably meant to be more generic. But obviously it is sort of the plumbing behind the scenes that works both for our Fieldprint Calculator, but also for our API partners. For all our partners, that data is, of course, entered in their platforms, transferred to Field to Market. We return the calculations. We don't store any data for our API partners. We only store it temporarily for the purpose of calculation and for logging for a period of time, I think less than a week now, but we don't store any input data from growers from a privacy perspective. It is a RESTful API using JSON as a format. We use OAuth for authentication. For field boundaries, we allow for GeoJSON or well-known text. From an input perspective, we have about 100 input parameters. Of course, that varies a little bit. On crop, alfalfa, for example, needs stand life, a number of cuttings, whereas corn or soybeans wouldn't need that. And then the management practice selections obviously influence the inputs. If I were to irrigate, obviously I have irrigation questions I have to answer. If I irrigated and used pumping that had energy, there are additional questions. So, but roughly we're talking around 100 input questions. It can pare way down if I were looking at a corn crop year with no irrigation, no drying, et cetera. The number of inputs is reduced greatly. We have, as an API, we have a primary calculation endpoint, and then about 30 related reference endpoints, and I'll touch a little bit more on those in a moment. So then thinking more broadly about Field to Market, we started out with our Fieldprint Calculator, but we realized, as everyone does, that we want to meet growers where they are. There is data fatigue. Nobody enjoys coming to the Fieldprint Calculator and spending an hour entering their data over again. So we looked at scaling our platform through an API and through a qualified data management partner program. We started this out before 3.0. We're probably a few years into this now. We certainly matured in our thinking and in our processes and our support, and as well expanded that partner network. This slide really doesn't do justice to the importance of that outside API partner program. We kind of formalized it a lot as a program to make sure that those providers, each of these are licensed. They're approved by Field to Market. I work with each of those partners to go through a QA process. What data inputs are you collecting? How are you getting them? Are they derived through remote sensing? Are they provided directly from the grower? Wanting to make sure that a supply chain partner, thinking back to my comments earlier, that there's a US Rice and a Ducks Unlimited and an NRCS and maybe a crop advisor and some growers engaged in a project, but now they want to use an outside qualified data management partner. And I'm making it up, but let's say Ag Connection through Syngenta LandDB, every grower happens to be using their platform. Wouldn't it be nice that then they could work through that qualified data management partner for data collection versus coming to the calculator? So that's the concept. So we formalized the program. We wanted all our partners to be very much aware of Field to Market's protocols, sort of the rules of the road as far as claims and verification, what it means to be engaged in a project, what type of data do you need to collect, what do you need to store, what type of data can you anticipate those project owners will want. So we have a formalized process around that qualified data management partner network. And these are 7 partners today. We're hoping to add another before the year is out. That's in the works with one of our partners, and then we're hoping to add 3 to 5 more in 2021. Some of the more recent ones, like the SEAM, who are working with the U.S. Cotton Trust Protocol, Bunge Centerfield, and Truterra came on most recently, and others have been founding partners for some time. And I can't stress enough sort of the partnership aspects of this network. I mean, we work routinely with our partners. They are part of what makes us improve over time. They're very giving of their time, given we've made some significant upgrades, and those upgrades continue. They're all very willing and supportive of the program. So, and there's a link there to learn a little bit more about that program. So just wanted to touch about the data inputs, data in general, data quality within our platform. This slide really doesn't present too much new, other than it's just sort of a block diagram of the data flow, looking from the left, the crops that we support, fed into an analysis at the crop year level, pulling in data that you would probably expect: land, field, geospatial, agronomic, operations, and then that crop rotation system that I spoke of for the NRCS models feeds into the metrics engine, fed in by model and model data, model data and other service data from NRCS through CSU, which then produces the analysis, and of course fed into whether it's the calculator or an external provider, one of our QDMP partners. So that's sort of how we view the data structure of our platform. It doesn't really get into the weeds of the exact data we collect, but I don't think much would be surprising. There is some more sort of qualitative data, things asking about 4Rs or what type of habitat potential do you have on your farm and things of that nature that may not be ordinarily collected. Those interested in our API, just to give you again a sense of this, we have primary endpoints. Calculator is the primary one, which all data is run. So everything is packaged into one large request against our calculator endpoint. We also call the soil service for soil data through the NRCS or USDA Soil Data Mart. There are some other endpoints there that we use, but the bigger batch then are our reference endpoints. And if you imagine our calculator UI or API partners UI, it is those reference endpoints that are used to build that out. So if I have to deliver to a user a list of available crops, or the pumping pressures, or different soil textures you can select from, all those reference endpoints, most of them will take them down locally and store them because they don't change often. But that's sort of how we're organized. So really the calculator endpoint is the primary driver behind our platform. And I apologize for those that may not be technical, because this may be really boring. This is just a quick example of a request, fictitious 2017 corn calculator payload. You can see there is some preliminary information at the top. In this particular case, the rotation that's being passed is an existing CRL mod template that's not modified, so they're passing their ID. You see the GeoJSON for the coordinates of this field. Further down in that payload, you kind of get to what is the rotation. That's really sort of the guts of it. As you sort of glance at that, you would see some of the data you would expect, right? Asking about, did you have a nutrient management plan? What was your soil condition for primary fertilizer application? Was it moist or frozen? Did you convert any of your land? What was your seeding rate? These don't show in a particular order in the request, but these are the types of inputs from the UI that are then, of course, packaged and pushed out into the request. And this is the tail end of that request. I've simplified this one. If there are no application trips here, you see towards the bottom, but one could have more than one application trips across the field, obviously in a season. And within each application trip, you would have one or more fertilizer applications or one or more protectant applications. And so you would see an array of those applications under application trips here. There's one manure application in this request, and you see that at the bottom. So from a simplistic perspective, that's what's passed over by a partner. That's what's passed in the back end of our calculator. Of course, the real work is getting to those data inputs from the growers and dealing with all the logic that goes around it. Just to give you a sense of what we've done in the background, how we manage what we do. So we struggled a lot with realizing that we have 7 partners in our own calculator and a lot of data coming over the fence. So as we built it out, and I should note, Houston Engineering is our ag tech provider. They built this for us, built it with us, and continue to maintain it. So we built in the background, for example, the ability to live stream that data. So this is an example. I ran the calculator on one hand and I opened up in the browser the other, and I could actually see a live feed of everything that's coming through the calculator. I see each of our partners' requests, and I could drill down and trace each one. So if there's an error, I could trace down and drill and get their actual request and the response and look at it and see whether anything is wrong or there's something wrong with the data. So in this case, just sort of a close up there, I can see in this request, which makes sense, I reran the same request. It used all the cache results. It didn't have to go to the model, and I'll talk about what we do with that. So this has been a really helpful tool. There's also the ability to see a summary every day of all the requests made to our calculator by partner and a summary of errors. So we can see, for example, we're seeing a lot of errors with bad crop rotation templates. Maybe they're using an unsupported crop in the template. We can begin to see that and then reach back out to our partners and say, hey, we're seeing 30, 40 errors. where 2% of the errors of 10,000 runs today came through with this error. Do we need to put up a knowledge base article, or is there something going wrong in the platform? So it's been really helpful for us. We also built things, not surprisingly, everybody would do this. We tried to, one of our challenges when you think about it was taking the metrics documentation from Allison Thompson's group, when they revised the metric specification and implemented that in the platform. We had to really make sure we could validate that. So we spent a lot of time building out the API in a really modular approach. So I can go in the background, I'm hardly technical anymore, and I could drill down to every aspect of our API, sort of the wrap part of the API that our QDMPs use. We have internal pieces. For example, I could open up our CRL mod service and I could punch in a CRL mod, a template ID, and I can track how much fuel is with each operation, how much fuel is for the leg, and the total fuel. We added that because we had questions about how much fuel shows up in a certain rotation. So we continued to build on that. And this is an example of drilling down to the land use, sort of the top part of that API request for the land use metric. I could actually put a payload in here and test out just that segment of the metric calculation for land use. And then also using a simple utility, we can actually see the data mapping, which gets really hairy when you look at like greenhouse gas energy. It's a bee's nest that doesn't fit on the screen, but it actually gives us a way to trace through all the inputs that go into each metric and then funnel through to the final metric calculation. That's been really, really helpful for us. So data quality monitoring, we'd also get the question of, well, how do you know the results are accurate? And obviously that's a broader topic. I don't think we answered the mail on everything, but one thing we did was we generated about 19 request test cases. And every night we run those against our metrics engine, and we run it against Colorado State University for the NRCS models. And that gets pushed out to myself, to Houston Engineering as our ag tech provider, and also Jack Carlson and Olaf David at Colorado State University. So any of us can see whether there's a problem. And if you look sort of towards the bottom on this one, on the 21st, there was an issue in CSIP at Colorado State University. Looks like 3 of the runs failed. Drilling down on that day, on 8/21, it looks like our alfalfa, barley, and the peanuts run failed for some reason. In this case, it turned out to be just some blip in the network. But we're able to drill down now, and you'll see that of these 19 test cases, we run different crops, we run slightly different managements, and we run them in different geographic areas of the United States to try to get some reasonable spread as we look at the QA of the data. And if I were to drill down on even one more on this alfalfa one, you can see here we have our baseline report data for that particular run against the model. But it failed. Obviously, it got no results in this case. But sometimes we've had cases where maybe there was a parameter tweaked in CRL mod, or something happened to the soil data mart, and something changed our results at even a minor level. Well, we'll see that flagged here. It could be totally fine, but it could be a flag for a problem. Things happen. So this has been a really, really good way for us to keep tabs on both our own metrics engine, that we didn't bugger something up on our own end, but also monitor the complexity that goes on at Colorado State University. We also looked at, and I'll credit Eric Cornell, he's in Allison's department with Field to Market, brought his expertise in data analysis and built out using R, using a Shiny app, if anyone's familiar with that, a QA tool. We're a project administrator, and we're hoping to allow our API partners to do this too. Take that output file and upload it into this R application and actually do some really good, helpful analysis on the data to try to find and fix problems. No matter how much validation we put in our UI, no matter how much validation we put in the API or our partners build into their UI, people will misinterpret units. They will just have bad data. They fat-fingered something. And we try to build in validation ranges so you can't put 5,000 or 3,000 bushels of corn when you meant 300, for example. So this new tool, which is separately hosted, but does great things. You can see, for example, in these screen grabs, we ran data and there were some obvious outliers. There's some data that obviously someone put in bad data, and someone needs to go back in and double check that in that project, reach out to those farmers and find out whether that was just a mistake. and I know that's kind of a tiny screen, but there's energy graphs there to get a quick perspective on sort of the results for different crop years within that project. Again, we've had projects with 500 growers and maybe 5 crop years each, right? So we have 2,500 records, whatever the number would be. It's a lot of data in that output file, and it's hard to visualize. So while we hope to do more of that in our platform and provide those QA tools, Eric, with his expertise, built something in R, and there's so much more you can do from an analysis perspective there. So, you know, there's so many problems that happen, and this has been we're really going to try to push this for our project administrators, and we're going to try to figure a way for our QDMP partners to dump their data in the same format so they can use this as well. So another thing we ran into was supporting our qualified data management partners. As I mentioned earlier, we have a formalized QDMP network, as we call it, to better communicate. We hold quarterly calls with our partners. We convene to talk about what are we doing wrong, where are we going, what are we updating. They always love to hear us say we're going to change something in the platform. For example, we're looking at moving to STEP instead of WQI for ag for water quality. Major change in our data in terms of the inputs. Some will have to add, some will deprecate. So we use those calls for that kind of discussion. And also, I needed a place. I used to have some documentation in SharePoint, I had some in a separate site. So now I've collapsed everything into what's a WordPress-based portal hosted on AWS, so that our partners could go in here. We have Swagger built into here so they can exercise the API from Swagger if they like. We're trying to build out a knowledge base of articles as well. So nothing formal here. If someone asks me a question, how do I build a grower a benchmark score? I'll try to put up a knowledge base article and so that everyone can share. And I also use it if we have a maintenance alert, I kind of use the WordPress plugin and I can fire it off to anyone that's logged in and subscribed to the portal. So that's helped. I mean, we only have so many partners, so this isn't widely used, but we want to build on this. So every partner we add has more knowledge to help with their integration. We have a API toolkit. We have sample request payloads and response payloads. We have examples of how reporting should look. What are the standards for your API integrations? So we have a lot up on this portal actually, and we want to build more help knowledge-based articles as we go. So moving into sort of the last section, I thought I'd share, again, sort of putting our honesty on our sleeve, some of the challenges that we've wrestled with. One of them is data volume for us. It's probably less of an issue than it was maybe even a year ago, but with 7 partners and hoping to scale to more, we have a lot of API volume. We'll have over 500,000 requests to our platform this year. We had almost as many last year. We usually get about 5,000 to 10,000 hits to the API every day. It depends. A lot of API partners rebatch stuff. They send them over and over again. So I don't want to suggest that of 500,000, each one of those is a single field. A lot of them are duplicates or they're running scenarios. When we do our own analysis, like a sensitivity analysis, we've run as many as 80-some thousand requests in a day against our own platform, sort of in parallel. So that volume question comes to our mind. How can we support that? What does it mean if we got to 10 or to 15 partners? I mean, when we have Syngenta and TrueTerra and Agrible, Nutrient at the table, and they really get all guns a-blazing, what is that going to mean for our platform? So, and then when when there's reporting at the end of the year, or we make a version change and everybody, like, what do we do down the road when we have all this scale of runs and then it has to all be rerun again? And what does that mean for us? What does it mean for our partners? So that's definitely a challenge. Processing time is kind of a hidden gem for us that maybe one wouldn't think about in a normal implementation. A lot of this stems from the model runs, particularly the wind erosion prediction project. The hydrology submodel, for example, takes a lot of processing time. A single year corn crop year running if everything's cached might come back to an API partner in 30 seconds. Maybe running something that isn't cached and it's a 5-year alfalfa rotation with corn or something on the end of it, it could take up to 4 minutes. So anyone involved in system design, that's a real fun scenario to deal with when you know that passing a call to the API could take 3 or 4 minutes to come back to. And what does that mean for your user? On our calculator, we do it real time, although a user could walk away from that screen and come back. They don't have to stay there. And most of our partners have gone to a process where they run things and then alert the user when their processing is done. So it's a real design consideration. We're hoping CSU, working with NRCS, there's this idea of meta modeling around the erosion. I don't know if we'll get there, but if they ever get to sub-second modeling, we'll be the first to sign up and look at that. That would be a game changer for us. So we're keeping our eyes open on that. Just integrating with models, with biophysical models like the wind erosion and water erosion, it has its challenges. It has unique data inputs like the crop rotation system I mentioned. Just understanding those models and what the sensitivity is to the inputs we normally have and what does it mean for the output. So there was a tremendous amount of time along the way in metrics development, but also in the implementation. I would say 20–30% of our work around integration on the back end of our platform is working with Colorado State University. It's not overly complex, but it needs a lot of hand holding. So that's certainly been a tough road for us, important to our program, but no less on the IT side, it's taken a lot of time and effort. This may get drilled down a little too much for some of you, but I thought I'd share some of the things we've dealt with. Some of the, we've dealt with memory issues. When we first went over to Amazon, we weren't using the API gateway or Lambda. We were using the Apache web server gateway interface, WSGI. We ran into some problems with that, so we did switch along the way. And as anyone familiar with AWS, of course, that's its purpose in life. We were able to spin up on-demand computing resources. So every request that comes into our platform spins up an instance. We spin up another instance to go to Colorado State, spin it down, do our calculation, and pass it back to our partners. So we did have to deal with a lot on that end as well. We had trouble as well with 30-second timeout for the API gateway on Amazon because things do take longer to calculate. So I take no technical credit here whatsoever. The guys at Houston Engineering, Andrew Shepard in particular, and Brian Fisher, in all these areas, I'm just parroting what I know. But we moved to use Pushpin, a utility. It's an intermediary protocol that allows us to simulate a long-running request and keep the pipes open, if you will, while those requests are being processed. The only problem we've had with that is there are some payload limitations for Pushpin, and that mainly occurs when people are passing geometries that are off the tractor and have a billion vertices and we don't smooth those out. So we've had some payload problems, but overall that's like a less than 1% error rate on that. So this has been working so far, in fact, better than we thought. A big thing we do is implement caching. We did this in our previous version. We used Redis, and now on AWS, we use Elasticache for Redis. When you think about it, when someone makes a call to our platform, we actually have to make multiple calls to Colorado State University. We have to make a soil call, then we call the water erosion, then we call the wind erosion, and then it comes back. And given that a lot of partners were hammering away with the exact same data, but maybe just a change in, let's say, whether they picked a certain 4R practice or whether they changed another field to market specific input, but had no bearing on the model payload, we want to cache those requests. So we try to cache anything that is duplicated when it comes across. And so we do that now. It's quite successful. It speeds up the response time. There's no sense going to Colorado State if we don't have to. We don't want to waste the time, and we don't want to waste their computing resources. QDP is going to override that. And also, every time we update the API, of course, we flush the cache so that there are fresh results. And there's a whole host of problems I could articulate around what do we do when we do upgrade a version, how do we push force recalculation. There's a lot of things that we're still wrestling with, but these were just some of the highlights. One thing I would comment here too, we thought early on about bringing the models internally and configuring them ourselves until we realized we don't have that expertise. We could have gone directly to NRCS, we think, and worked maybe through their data center, but we did opt to work with Colorado State University. They have a model as a service, their cloud, their integration platform, their, again, model as a service, and they've continued to build their capacity their reliability for CSIP. Olaf tells me they can run up to 50,000 model runs for WEP and WEPs. That's far more than we need. Plus there's a queuing mechanism here. So it's really just a matter of time, not overburdening the system. And we spend a tremendous amount of time with them. We have weekly calls with Jack Carlson, Olaf David. We're very thankful. Mike Casera, if any of you work with on the erosion side, and Chris Coriel, the national erosion specialist. We're so thankful we have that expertise every week, whether it's looking at upgrade to step or maybe something simple. We're getting really strange results. We had something come up a few months ago where erosion values were crazy, and I learned a good lesson about calibration mode of the models on sandy soils and low precipitation. And had we not had that expertise at the table to understand that and sort of change what we were doing internally and communicate to our partners, we would have been dead in the water. So again, we're really thankful, and again, all supported through NRCS. As a couple more slides, I just want to mention, some of the things we're thinking about down the road, getting to sort of the last slide here. We do want to build out more of a pub-sub mechanism with Colorado State University, or probably more probably a webhook, so that our API partners don't have to spin up and wait for us as well, so we can all sort of ramp up, ramp down on the computing. And so we're looking at that. We actually need to catch up with some of the work that Colorado State University has done. So we hope to do that this year. We need to do a lot of improvement around validation, both within our calculator and in particular, you can't run a 2020 corn crop year and not put corn in your crop rotation system, but you could add a fertilizer application and not include it in your crop rotation system. So we need to do a little bit more validation and find ways that we can help the user build out those crop rotations without having to feel like they're duplicating data entry. And related to data entry, we want to look at use of remote sensing. There's obviously some things in our own platform, and our partners are already doing this. I should point out one of the primary reasons for extending our platform to partners that you saw, the Syngenta, Nutrien, Agribal, My Farms, is because they are doing what we can't do, that we don't have a budget for. Not only can they expand and build around more robust functionality around those sustainability metrics, they can present a grower with agronomic insights next to sustainability. Okay, I do this on the agronomic side. What does it mean for sustainability? Why does the supply chain care about that? If you look at tools such as Truterra, for example, trying to match out, well, if I made these changes, how can I look for cost sharing resources within NRCS? So, I have to say, we look at our calculator as sort of baseline functionality, and our partners really build on top of that and innovate around it. And they are already looking at ways of using remote sensing. We ask questions such as, did you change your land type in the last 5 years? We asked that, but of course we could tell that. Do we need to ask them what their rotations were when we could go to Cropscape and pull out that data through some of the layers there? We could. We have to decide what we can afford on our side, and probably more likely allow our partners to expand and build on that. We want that. We want to promote our API partners and encourage supply chain partners that are part of projects to work with those QDMPs. We think that's important. We want them to come to the calculator, but I would note that probably 70–80% of the data in our platform as a whole comes through those partners now. We expect that to increase. The platform will always be, the calculator will always be freely available, sort of serves as a sort of a showcase for what our sustainability program does. But ultimately, we want all that data and that processing to come through those partners. We also need to look at how we reduce integration costs. Every time a partner invests in the integration, it is not simplistic, as everybody I know knows. So the cost of rebuilding a UI, the cost of how do I build a crop rotation system. They have the data, but it's got to be in our format. And it's probably not something they're using elsewhere. So there's obviously cost to that. And so we need to look at ways. We're working on some. We also have a technology advisory council. In fact, Dorn we're very thankful is on that technology advisory council, and some other good folks now to look at some of these questions. And then smaller things like how can we better use Amazon Web Services, like improving our database connection capacity. We do get some timeouts at time, and we want to look at, for example, at AWS Aurora, sort of a stateless, if you will, type a database approach. So that's an example of some of the things we do. There's a laundry list in our roadmap, but that's the flavor. And then lastly, I think all of you probably have your understanding with OpenTEAM. I duplicated some of the things that are in our memo. These may be common among all of us here associated with this group. But I think you could imagine, as you think back to some of the things I presented, thinking about the inputs that we have to gather, how common are those? Who else is gathering the same thing? Can we come up with a common standard? Are we calling a crop rotation versus a crop rotation template? What's that common vocabulary? How can we use remote sensing? If we move to STEP, we're going to be concerned with soil sampling because it requires a lot more, it has greater importance on soil sampling. Are there things like with land PKS that I'm learning about through OpenTEAM? Could that play a role? So this cross-pollination for us is really huge. And we're hoping we can learn a lot. I'm hoping we can share through a presentation like this. Someone will say, oh, I see what you're doing with NRCS, or I see what you're doing with your metrics, or how are you handling recalculation of 7 API partners, and what's the protocol around that. So we really think this is a great environment to share, and so I would just close out by saying we're really, really thankful to have this opportunity to be presenting here, but also be part of OpenTEAM. So I'll leave it there with questions if there are, and that's the end.
Great, thanks so much, Paul. I have some thoughts that I could add, but we only have a few minutes left, 7 minutes. So are there questions from the group?
I know that was a lot to run through. I feel, as I always do, I should have cut out some slides, but.
Oh, I thought that was great, Paul. And in fact, I mean, I think some of your last slides were right on with some of the questions that I think we normally queue up for you. So thanks so much for that. I wanted to, first, thank you again so much. And it's really impressive, again, the level of collaboration, the numbers of partners and intersections, and I think the knowledge that you're bringing in terms of managing that complex ecosystem and those associated challenges is really valuable. I wanted to, perhaps to reflect a bit in terms of, to dive into your reference endpoints and our conversation around, microservices and accessing libraries, and your thoughts on managing version control, or what you've already been doing. And then I know that's a big topic in terms of currently within the OpenTEAM community.
Yeah.
So,
I mean, I think for us, I mean, I had a conversation with one of our API partners who rightly scolded me on the reality that for them, as supportive as they are of our program, there is a cost to them. They have to justify an upgrade. They have to go back to the well and say, we have some more technical work to do to keep pace with field to market. And so there's an understanding that these changes better be significant, they better be meaningful. And then on the other side of the equation, we have membership in the supply chain driving. And I think the water quality is a great example. Again, Allison Thompson, that's her area. She would better explain it. But there was a general feel through the metrics committee and science advisory that we have to look to that and make that change. So we're going to have a significant version change in our metric. It's going to be a 3 dot something. And so we're trying to develop a process where we work with our partners and sort of forecast. We're trying to do science releases every year in June. Some of those releases might be minor, some of them might be major. STEP is a great example. That's not insignificant, not just because of the technical change, because what it means to their program. And I'm often reminded that for us in our calculator, it's a small world. If I'm a LandDB, a mature product with a huge product to manage, a small change has a lot of ripple effects. So we are trying to be more mindful, more careful about the changes we make. We also are, and I'll give you a quick example and then end here. Even internally in our own calculator, one of the things in our backlog that I'm bringing out this month is if I'm a project owner and I had 100 growers that have already had all their data in, and I continue to add growers, but we make some slight index to the version. Right now, the admin wouldn't know that. Now, if I'm CHISRA, who manage our claims and verifications, I care a lot about that. Did that data output, was everything on the same metrics version? So now we're going to create a report that flags something either through notification that says, wait a minute, because we do store the version in the response payload that we store and hold in a JSON format. We can we can interrogate that and say, wait a minute, out of those 100 growers and maybe 300 crop years, there's 25 of them that are an older version. Before you report, you must recalculate. That's manageable in the calculator, but for our partners now, they all have to implement that same thing. And then when I think more broadly and I go, oh, great, we made a version release, and now I've got all 7 partners deciding to run all their data for recalculation. And what does it mean for older data that was calculated before? I mean, we're a continuous improvement program, so we always want to rerun everything and look at it again. But what if I was doing great one year and then I recalculated and I'm not doing great this, so there are a lot of questions. We haven't answered them all. We're working internally to kind of look at what is that impact of the versioning. The problems are far from technical. They're more program related for sure. So yeah, we're trying to address some of it, the more obvious level. And then, team members such as Allison and Chisa are working on what it means from a claims and verification perspective, so there's definitely integrity in the data that projects are using. I don't know if that got to what you meant by managing versions, but those are some of the challenges.
Absolutely. Thanks so much, Paul. Other questions or comments before we close out at the top?
Hey, I had a question quick. We've been, just super impressive. Everything you present is just super impressive. And you've done a lot of integrations with a lot of groups, and we've been talking about, the sort of API switchboard or some kind of integration solution to reduce the number of APIs that need to get managed. Given that you've done all that work, do you have a perspective on that? And 2, would that even be valuable to a group like you that's already done so much of the work? Or, just general, just curious.
Yeah, that's a great question. I don't know if there's, I'd like to think, and I don't have enough perspective that, we're not the only ones using the NRCS services or the USDA model and data services at Colorado State University, for example. So there's probably something to think about there. We're not pulling off machine data. And again, I'm thinking about the calculator for a moment. I just had a conversation with an NRCS call about our grant to look at data sharing between field to market and CART and RSET. And the one deficiency we have is with the soil data. So I was thinking about land PKS, right? And then, we were talking with Jack Carlson about, the rotation. Why can't we get that through Cropscape or I think it's their LAMP service. Yeah, I'm not sure yet. We're struggling with having to go through a lot of different APIs. I don't know that I have enough perspective yet on the landscape of where the needs are across all the people participating. So I'm interested in that. I listened intently the other day, or was that yesterday, the day before, about that discussion. And I'd love to explore it more because, we're a member-led nonprofit and our budget is extremely limited. And so, we obviously want to maximize our membership value and look for ways of doing things, in an economic way, if you will, technically. So that's not a good answer other than to say we're interested in figuring out if there's some opportunity there.
Thanks.
Thank you so much, everyone, and thank you, Laura, for hosting us today, and thank you, Paul. And
thank you.
As always, we have so many more questions, and look forward to following up and seeing everybody on the next in-depth and Ag Data Revolution conference too, if you're able to register for that. So,
and our
thank you.
One other thing, our next in-depth is on September 10th with Light Farm, and Kevin Kusin will be presenting their project lead. And then, yes, please register for the Ag Data Revolution, September 24th and 25th. So I can drop that link in the chat in a moment. Thanks.
Yeah, and thank you. Thanks for letting us share. Appreciate it.
All right.
Thanks,
Paul.
All right.
Thanks, everyone. Bye.
Bye, everyone.
There's the link to the Ag Data Revolution conference if anyone would like to go.